Allow me take you through organic chemistry 1 and 2 revision. I want to revise with you as you prepare for your exams. Organic chem, this is a topic which comes in paper 2. Also it can be there in paper 1, and we have it in paper 3. It is a very common question which we not miss. Actually, there is no exam I have seen that has missed organic chem. Therefore, you need to prepare for around 12 marks in paper 2, some 3 marks in paper 1, and some 10 marks in paper 3 for organic chemistry. So it is important. I want to take you to the basics of organic chemistry. In organic chem, you need to understand the functional groups. Functional groups. So organic chemistry, from organic 1, we studied what we call alkanes. We studied the alkenes and then alkynes. This is what we studied in organic 1. So here we saw that alkanes, these are compounds which have a single covalent bond. A single covalent bond. Alkenes, these are compounds whose functional group has a double bond. Double covalent bond. Also, when you are writing these functional groups, ensure that the carbon is surrounded with 4 covalent bonds. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Each carbon must be surrounded with 4 covalent bonds. And the alkynes we learned in Chem 1 is that this is they have a functional group of a triple bond. So one bond, so that now each carbon is surrounded with 4 covalent bonds. In organic 2, we learned the other 2 or 3 functional groups: the alcohols, alkanoic acids, alkanols, we call them alkanols, not this one, alkanols. The alkanols or alcohols, and then we have alkanoic acids. So we in form 4, that is organic 2, these are the major functional groups we learned. An alkanol has a functional group of ROH. So any alcohol must have a OH group, functional group, for it to be called an alkanol. For example, ethanol, propanol, butanol. Therefore, it has OH. The name finishes with OL, ethanol, like that. Alkanoic acids, they have a functional group of RCOOH. R stands for a long carbon chain. R stands for carbon chain. For example, when we have ethanol, it is 2 carbons. Propanol, 5 carbons. Propanol is 3. Pentanol, 5. So R stands for the number of carbons that are contained in that alkanoic acid or in that alcohol. So these are the functional groups which are very, very critical in paper 3 and even in paper 2, also in paper 1. It is important you understand that. So because I said this one is a revision, I don't want to teach. So let me take you to a question I want us to look at. Let us look at this question. Draw the structural formula of the following organic compounds. The organic number 1 is 2-chloropropan 2-ol. Ol is the functional group which gives you that this one is an alcohol. It is an alcohol. Ol. Propan gives you the number of carbon atoms. The parent name of this alcohol is propanol. So, but the OH is in carbon number 2. That's what it means. And then in carbon number 2 also we have the chlorine atom. That is the substituent group. So now we start there because we are drawing the structure. We start from the name propan, which will give us 3 carbon atoms. That's 1, 2, 3. And then these 2 will tell us that the OH is in carbon number 2. So 1, 2, OH. Also in carbon number 2 we have chloro. So we have Cl. And then after we have done that, the remaining part you fill with hydrogen atoms. You fill with hydrogen atoms like this, like that, ensuring that each carbon is surrounded with 4 covalent bond. And this is the 2-chloropropan 2-or structure. This is how it looks like. Another one is butyl ethanoate. So butyl ethanoate is an ester. You should remember that. This is an ester. And remember, how do we form an ester? For example, this one, butyl, it means that butanol, C2, C4, or we can have CH3, CH2, CH2, 1, 2, 3, CH2OH. This is butanol, 1, 2, 3, 4. This is butanol reacting with from ethanoate, therefore it is ethanoic acid. Ethanoic is CH3, COOH. This is called ethanoic acid, and this is butanol. So butanol, when reacting with this one, it will give you an ester called butyl ethanoate. Then the first part of the name butyl comes from the alcohol, and the ethanoate part comes from the ethanoate part comes from the acid. So we want to draw the structure. Actually, this one will give you this. So it is important that you know this one will give us the acid CH3, COO, and then you copy everything from here up to here. This is 1, 2, 3, 4. So I can say C4, I'm an hydrogen, 1, 2, 3, 4, 5, 6, 7. H7, and then plus water. That is the structure. So what we are asked to draw is this. This is what we call butyl ethanoate. So how do we draw this? This, you start carbon, this carbon, and we have another carbon here. You can see we have how many hydrogens? 3. So put 1, 2, 3. This carbon has oxygen. When we have 2 oxygen like this, it means one has a double bond. Therefore, in this one we have sure 1 to correct. Therefore, we have oxygen here, and then we have another hydrogen here. O, we have 2 oxygen atoms here. Therefore, one has a double bond, and we have another one which has a single covalent bond. And then now here we have 4 covalent carbons, 1, 2, 3, 4. So 1, 2, 3, 4. We have sense. Therefore, you should, like we have said, you should ensure that carbon is surrounded with 4 covalent bonds. Therefore, one hydrogen will be down, another one up, like this, like that, like this, like that, like this, like that, like that. And by so doing, this is the structure of butyl ethanoate. Butyl ethanoate. The first part is an acid. The second part is comes from the alcohol. So this is what you are supposed to draw. Only this. This one I just wanted you to see what you are supposed to do. The next one is 2,3-dimethyl pentan 2-ol. Pentan gives us the parent name that the alcohol has 5 carbon atoms. So 1, 2, 3, 4, 5. The parent is penta. Penta means 5. Carbon number 2 has the alcohol, the OH. So carbon number 2, OH. So 1, 2. I have started counting from this. You can also start counting from this side. It doesn't matter. So 1, 2. I have this one, and then carbon, the same carbon number 2, we have methyl group CH3. but the methyl groups are two of them, because that's why we use dimethyl. So we have another one, carbon number 3, 1, 2, 3. We have another one here. So once you have done that, the rest of the remaining, you add hydrogen atom to ensure that the carbon is surrounded with 4 covalent bonds. And this one is what we call 2,3 dimethyl pentan 2-ol. Give the names of the following compounds: 1, 2, 3, and you can see OH here. OH stands for alcohols. So this is alcohol, an alcohol. Therefore 1, 2, 3, 4. But the OH is in carbon number 2, right? Therefore the name 1, 2, 3, 4, that is butan 2-ol. Butan 2-ol, because for alcohols we call them butan 2-ol. This is 1, 2. You see oxygen. One oxygen tells you it is an alcohol that has reacted with potassium to form. So the name here is potassium ethoxide. Why did I say ethoxide? The number of carbons is 1, 2. So it is ethanol that reacted with potassium to form potassium ethoxide. This one, I want to change the name. CH3, CH2, CH2, COOH. And this one is 1, 2, 3, 4, and it is called butanoic acid. So when the number of oxygen is 2 in a compound, that this one you should tell you that the organic compound, this one is an alkanoic acid. When the oxygen is a single oxygen, it tells you it is an alcohol. We have a polymer here. This one is a polymer. A polymer has the following structure. Draw the structure of the monomer. Remember, a polymer is made of a monomer plus a monomer plus a monomer. A monomer repeats itself to form a polymer. So draw the structure of the polymer. So when you want to determine the structure of a monomer from a polymer, then what you look at is the repeating unit. In that polymer, what is repeating itself? So let us look at the repeating unit. Look at the repeating unit. CH2, CH1, and then it is 1. So you see it is from here up to here, it starts repeating itself. So the repeating unit, as you can see, it is this unit. Repeating unit, it is this unit that is repeating itself. Are you seeing that? I hope you have seen now. That one is the repeating unit. So when you want to draw the monomer, remember it is the alkenes which undergo polymerization. So therefore, when you go back, you have to go to alkenes. So therefore, this is CH2. I will put a double bond here because the double bond broke to form that CH3. And this is the monomer. It means it was 1, 2, 3 propene plus propene will form this polymer called polypropene. This one is polypropene, repeating itself. You can also write it as this: carbon, double bond carbon, one hydrogen, one hydrogen, then CH3. This is the same as this one. So this is what we call a monomer. So a monomer plus another monomer, we form a polymer. A sample of a polymer is found to have a molecular mass of this, determining the number of monomers present. So first, if this is the molecular mass of the polymer, and remember it is a monomer plus a monomer plus a monomer forms a polymer. If we have a polymer, we can get the number of monomers present by first calculating the mass, the molecular mass of one monomer. So we have one monomer here, which is 1, 2, 3, which has 3 carbon atoms. 3 times 1 carbon is 12. Plus, how many hydrogen does it have? 1, 2, 3, 4, 5, 6. 6 hydrogen. 6 hydrogen times 1 is 6. So when you multiply this times several monomers of this kind, you get the mass of the polymer 6426. So this is 36 plus this is 42N will give us 6426. So we want the number of monomers, which is divided by 42 divided by 2, and N equal to 153. So there are 153 monomers making this polymer with molecular mass 6426. The structure below represents a cleansing agent, which is said to be both a pressing and a cast. So this bleaching agent is said to be a pressing and a cast. Which type of cleansing agent does the structure above represent? So we have two types of soaps or cleansing agent. We have soapy and a soapless detergent. Soapy are the bar soaps. The bar soaps like Center, or those bar soaps you use, they are called soapy. And the soapless detergents, they include Omo, Aereo, the liquid soaps. All of those are called soapless. How do you know a soapless detergent from a structure? Soapless detergent, they have the sulfonate group. This group here is called the sulfonate group. And it has a ring of benzene ring, this benzene ring. So whenever you see the benzene ring and then you see the sulfonate group, always be aware that that one is a soapless detergent. A soapless detergent. But the other one, the soapy detergent, soapy, has got the carboxyl group. Has got a carboxyl what? Group. Therefore, you can differentiate that very easily. So this, what name it is? A soapless detergent. How is it a blessing? You remember soapless detergents like Omo, Aereo, all those in powder form, they are not affected by hard water. Therefore, they are very soluble in hard water forming. Therefore, yes. So it is very soluble in hard water, hence does not form scum. It doesn't form scum with hard water, therefore it is a blessing. And how is it a cast? Soapless detergents are non-biodegradable, most of them, so therefore they cause water pollution. They cause water pollution because some are non-biodegradable. Some are non-biodegradable. Study the scheme below and answer the question that follow. Substance Y. Step 3. So when you have a scheme like this, it is important for you to look at the arrows. Where are the arrows coming from and where are they going to? So this means that this process is going up because the arrow was there. This process starts from here going this way. So the source of this is this. That is what it means. The source of the polythene is from step 5 this way. Therefore, it is important for you to look at the arrows and see which direction they are facing. Now, when ethanol, this one is ethanol 1, 2, because 2 carbons, ethanol combines with ethanoic acid 1, 2, it forms an ester. So the step 3 is esterification. You need to esterification. Ethanol undergoes step 1, and you are seeing acidified potassium manganate, the manganate, which is an oxidizing agent. Therefore, ethanol will be oxidized to ethanoic acid. So K is ethanoic acid because this is oxidation. Ethanol undergoes with oxygen. Anything that undergoes when oxygen is added, that one is combustion, burning, combustion. When ethanol undergoes a certain process and ethene is formed, this is ethene 1, 2, then this process is called dehydration. As you can see, these are 2 carbon atoms, 1, 2, 1, 2. What has been removed from here is water. Look at how many hydrogens are here. 1, there are 6. How many are remaining here? 1, 2, 3, 4. So water has been removed. And the process of removing water from a substance is called dehydration. What are the reagents that are used in dehydration? It is conch sulfuric acid that is used to dehydrate, and then a temperature is required. Step 5. Ethene is going a certain process and polyethylene is formed. So this is polymerization. And as a form 4, you don't just write polymerization because we have 2 types of polymerization. We have addition polymerization and then condensed polymerization. This one is addition. Addition polymerization. Addition polymerization. After you have done that, so you need now to come to the question. Name 2 conditions necessary for step 2. Step 2 is dehydration, we have said. So one condition is that concentrated sulfuric 6 acid is required. Another thing that is required is temperature of 160 degrees Celsius to 180 degrees Celsius for step to occur. Name the process in step 1, step 2. We said step 4 is combustion, step 1 is oxidation, step 2 is dehydration, and step 5 is polymerization. Step 3 is esterification. So therefore step 1 is oxidation, addition of oxygen. Step 2 is dehydration, removing of water. That's what it means. Write equation for step 3. Step 3 is esterification. So we write the equation of esterification, that is step 2, that is C2 ethanol, which is reacting with, you can see, ethanol plus 1, 2 ethanoic acid. Ethanol plus ethanoic acid, we are going to form ethyl ethanoate. So plus ethanoic acid, we form plus water, and this one is called ethyl ethanoate, and it is an ester. This is an ester, and the process is esterification. Write the chemical equation for the formation of substance Y. Substance Y is the ester, and we have done that. So the one we have done is the same, so this one we repeat it here, and that is all. The equation for the formation of Q. So we go to substance Q. Substance Q, it is the combustion of ethanol. When ethanol is an organic compound, when it burns, it forms carbon dioxide and water. So gas S is carbon 4, liquid Q is liquid water, the water. So you should know that. Now ethanol plus oxygen, it burns to give us CO2 plus water. Carbon here, there are 2 of them. We balance that like that. So 2 carbon, 2 carbon. Hydrogen here, there are 5 plus 1, 6. Here there are 2, 3. So there are 2. So 2 times 3 will make 6. In the process, oxygen atoms here, there is 4. 4 plus 3, 7. Here we have 1, 3. So if we multiply by 3 here, we will have 6 plus 1, 7. And that is all. Status, this one is a liquid, a gas, liquid. Formation of K. Formation of K. K is ethanol reacting with undergoing oxidation. So that one is simple. So ethanol C2H5OH in the presence of it's acidified, so it forms ethanol, ethanoic acid, CH3COOH. Oxidation, formation of gas S, that is combustion. It is the same gas S and Q are formed at the same time, so this one is actually this. Here is another question. Study the flow chart below and answer the questions that follow. So first, before even you go to the question, analyze this flow chart, know every step, the name of every step, what's happening before you go to the question. So let us start step 1. Step 1, what's happening? First, this, what is this? This is a double bond, therefore 1, 2, 3. This one is propene. This is propene. So propene is undergoing step 1, forming propane. Yes, this one is propane. So what is that? So step 1 is hydrogenation, addition of hydrogen in the presence of nickel catalyst. So that's the thing. Now propene is undergoing step 3 and it is forming a polymer. We know this one is a polymer, right? Therefore step, this one is polymerization. So we know step 3 is polymerization. Let us go to step 2. So propene, how was it formed? It is formed from 1, 2, 3 ethanol, OH from ethanol. So we are forming this. So in step 2, what happens when ethanol is forming propene? The water inside it is removed. So step 2 is dehydration, removing of water to form propene. Propanol, water in propanol is removed to form propene. Ethanol is reacting with potassium in step 7 to form liquid X plus gas M. That is okay. Step 5, ethanol is reacting and is forming propanoic acid. That is oxidation. Remember, oxidation requires acidified potassium permanganate. Acidified potassium permanganate. Acidified potassium permanganate from that. The next thing, so here, how was this ethanol formed? Ethanol was formed from sugar. So remember how ethanol is formed. And remember, this one is propanol, but whether it is propanol, pentanol, whatever it is, it can be formed from sugars. Therefore, propanol is formed from sugar. Which step is this? This step we know it is called fermentation, where sugars are hydrolyzed. That the sugars undergo decomposition using the yeast, the enzymes to form alcohol. Now propanoic acid in step 6 is reacted with corn sulfuric acid plus ethanol. It forms L, and L, whenever you see this propanoic acid and ethanol in the presence of sulfuric acid, that one is esterification. Esterification. So this one is an ester. L is an ester. So you see, we have did the analyzation. So once we go to the questions, you will just be picking the answers from here. Thank you. So let us go straight to the questions. So the questions here have a total sum of 11 marks up to here. So in fact there are 12. There is another question on the other side. So make sure you score all of these marks in organic chemistry. So question 1, name the type of reaction. Name the type of reaction in the following steps. Step 3, step 4, step 3 and step 4. So we go back to the chart and then see step 4. What kind of reaction do we say is there? The reaction in step 3 is polymerization. The reaction in step 4 is fermentation. So these are the things we are going to write there. But remember, we have two types of polymerization. We have addition polymerization and condensation polymerization. This one is addition. Therefore, the correct answer for the reaction taking place here is addition polymerization. Addition. So this one is addition polymerization. Step 3 is fermentation. Name the important reagents and conditions in step 1, step 2, step 4. So we are looking for the reagents in step 1, step 2, and step 5. Step 1, step 2, and step 5. So you go back to the chart and then step 1, it is hydrogenation. So the reagent is hydrogen. The reagent is hydrogen. And then the condition is that we must have a nickel catalyst and a temperature of 150 to 250. Remember that, 150 to 250 temperature. So those are the conditions. The reaction in step 2, where is step 2? Step 2, step 2, step 2, step 2. Here, step 2 is dehydration. We did that. Dehydration is the removing of water. Therefore, it requires concentrated sulfuric acid. Dehydration requires concentrated sulfuric acid and a temperature of 160 and 180 degrees Celsius, between 160 and 180 degrees Celsius. Step 5. Step 5, it is oxidation, and oxidation requires acidified potassium permanganate. Because it is acidified, so we use a sulfuric acid and potassium permanganate. So the reagent is potassium permanganate. The condition is that we need sulfuric acid because we need the acid to be acidified. So this is the process is hydrogenation, and we need hydrogen. And then temperature, the condition is temperature of 150 degrees Celsius to 250 degrees Celsius in the presence of nickel what? Nickel catalyst. Nickel catalyst. The presence of nickel catalyst. Step 2, we have said it's dehydration. Dehydration, the reagent is concentrated sulfuric 6 acid. The condition is temperature of 160 degrees Celsius to 180 degrees Celsius. Step 5, we said it is oxidation. Oxidation, the reagent is acidified, actually because of the acid, it is potassium permanganate. 7. The condition is that we need sulfuric acid. Sulfuric acid, it should not be, it's not a must for it to be a conc. Sulfuric acid, sulfuric 6 acid is required to make this potassium permanganate acidified. So those are the conditions required there. Write a balanced equation for the reaction taking place in step 6. Step 6. So we'll go back to the chart and see step 6 what is there. So step 6 is here. It is the formation of an ester, so propanoic acid plus ethanol. Very good, to form an ester. So we are going to react propanoic acid plus ethanol to form an ester. So propanoic acid is CH3, CH2, COOH, that is propanoic acid, and then plus ethanol, CH3, CH2OH, which will react in the presence of sulfuric acid. A few drops of sulfuric acid, it will form ethyl 1,2 CH3 CH2 OS, and then C OO, and then this one now combines it there, which is CH. We can combine 2C, and how many hydrogen? 1, 5, and then plus water. So this one is called, anyway, we have not been asked to give the name, but it is called ethyl 1, 2, 3 propanoate. Ethyl propanoate, that is the name of that. Step 7, the reaction in step 7 is where ethanol is 1, 2, 3 propanol. Propanol is reacting with potassium to form the salt, organic salt, plus hydrogen gas. Gas M is hydrogen. So C2, CO3, that is H7OH. I have shortened ethanol, plus 2K, to here, will form C3, H7OK. This one is called potassium propoxide plus hydrogen gas. Liquid X is potassium propoxide, a substance which is the ester. The ester is called ethyl. This ester here, ethyl propanoate. Ethyl propanoate, that is the name of the ester L. Step 2 chemical test used to differentiate between alkane and an alkene. So this one is propane and propene. How can you differentiate between propane and propene? Propane is an alkane, propene is an alkene. Remember, alkenes are unsaturated, while alkanes are saturated. I don't know whether you know how saturated alkanes what they are and unsaturated what they are. But now I'm going to differentiate. We have been asked two chemical ways or to differentiate between alkanes and alkenes. So the first thing you should know is that, because now this we are talking about specifically, we are going to use acidified potassium permanganate or bromine water. So we are going to say that this one, C3H8, which is an alkane, or we start with 6, an alkene. CH3, which is an alkene, will decolorize bromine water. Bromine water will decolorize bromine water, or acidified potassium permanganate, which is purple. It will be decolorized. But C3H8 will not. So alkene will decolorize bromine water, but alkane will not, because alkanes are saturated, alkenes are unsaturated. The next test is burning. When alkenes are burnt, they burn with a yellow sooty flame. When alkanes are burned, they burn with a blue non-sooty flame. That's another way you can differentiate them. Therefore, C36 burns with a yellow sooty flame, while C3H8 burns with blue non-sooty flame. So by burning that, you can differentiate it like that. If the relative molecular mass of a compound formed in step 3 is this, determine the value of N. So let us go to compound step 3 and see the compound that was formed. Step 3 is addition polymerization. So this one is a monomer. So we are going to calculate this one monomer. So N is missing here. This one monomer. So we are going to add this monomers 1, 2, 3, 36 plus 6. It is 42 N. Therefore, our monomer is CH3. CH double bond is CH2. So get the 1, 2, 3. We have 3, 2, 1, 2, 3. 3 carbons times 12, each is 12, and then plus 3, 6 hydrogen times 1. Everything times N will give us 42,000. So this is 42N. 36 plus 6 is 42 is equal to 42,000. So it means that N equal to 1,000. So the monomers which will form a polymer with a molecular mass of this is we will need 1,000 monomers. State 1 disadvantage of continued use of items made from compound formed in D above. The compound formed in D Roman 1 is a polymer. What are the effects of polymers? Polymers, they cause pollution. The compounds formed there, they are called polymers, and they cause pollution. Why? Because they are non-biodegradable. So you say the compound formed are non-biodegradable. They don't decompose. Polythene things, that's why polythene papers were banned, because they don't decompose. Therefore, continued use of these items of polymers is going to pollute the environment, because the compounds don't disintegrate. They are non-biodegradable. Thank you for this lesson.